Hello and welcome. This video is on pivot tables in R and R-Instat. We look at three data sets and start with a simple example of experimental data. Use import from library with the AgriTutorial package and choose the green rice data. The experiment had 64 plots. Returning to the import dialog, the R help shows this is an example of nitrogen uptake from Gomez and Gomez. There were 4 water stress treatments on main plots with nitrogen rates as the subplot treatment factor. The textbook layout of the data is a table in Gomez and Gomez. The pivot table dialog is in the Prepare Check Data menu because of its role in data exploration. It is also in the Describe 2/3 variables menu because of its data summary role. It's the same dialog, so use it from either place. Completing the dialog is optional as the OK button is immediately available. This time, we take advantage. Use Prepare, Check Data, Pivot Table and click OK. Then click on the Maximize option in the Output window. We now match the data layout in the book. So, drag Replicate to the column field, then drag W followed by N to the row field. This is already often a useful step in the data checking stage. The result confirms that these 3 variables seem to have been entered correctly. They each have the expected 4 levels, and the full set of 1s confirms that the experiment is perfectly balanced. Click on the count in the pull down and change it to average. A new field is now visible. Choose Uptake. This shows the pivot table version of the same data layout as in Gomez and Gomez. Click in the field saying Table to show other options and choose Heat Map. Now, the larger the value, the darker the red. The most obvious feature is the low levels of uptake with almost no red for the 40-day water stress level. And at that level, the nitrogen seems to make no difference. It also makes less of a difference at the 20-day water stress level than the other 2 levels. There doesn't seem to be any column effect, so we could not anticipate much of a replicate effect. On oddities in the data, the 0.68 uptake for the 4th rep shown here looks surprisingly low. Nothing else seems to be an obvious outlier. Now, start summarizing the data. Move the replicate to the top. Move N from the row to the column field. This provides a useful summary table. The different color pattern for the W levels confirms what we saw earlier. Namely, the 2 factors need to be considered together. The effect of N on uptake depends on the level of water stress. Perhaps a graph will make the result clearer. Return to the drop-down that currently says Heat Map. Change this to a line chart. This is now an easy set of results to interpret. At 0 or 10 days of water stress, there is a steady effect of increasing N. At water stress of 20 days, that's the yellow line, there's perhaps slightly less uptake at the low N levels and no additional uptake from the higher levels of N. At the highest stress level, there is only low uptake and no effect of increasing N. Many people love bar charts more than any other graph. Return to the line chart and change it to bar chart. How easily can you interpret the results? Although most people seem to prefer bar charts, I suggest, at least for this data, that the line charts are simpler to interpret. However, let's give bar charts another chance and change to horizontal charts, return, and change the chart as shown. Finally, swap N and W, then have an ordinary bar chart. That's possibly the best you can do with bar charts, and this can be interpreted as for the line charts. While the bar charts are certainly colorful, we prefer the line charts to facilitate a discussion of the results. The second example is a small survey from Omani. The data are in the R-Instat library. Use import from library from the front menu or from the file menu. Go to the Research Methods for Agroecology directory and click on the Omani file. Then click Open and select the household data sheet and click OK. We confirm there are 66 rows and 30 variables. Each row gives details of a household in one of the years. So, the first respondent in 2007 was from Sharaya village, had ID code SH1, was also a respondent in 2018, was in the household of 12, and the head was 55 years old. Go to Prepare, check Data, Pivot Table. In the dialog, the row variables are village and HHID, while make year as the column variable. Then, put just the first variables, perhaps down to the age HHH, into the select variables receiver. As long as you include the household size and the remained columns, we don't plan to use the others. Then press OK, then use the Maximize button in the output window. The result confirms we are looking at individual values. There are just ones or blanks in 2007 and 2018. And scrolling to the bottom confirms there were 38 households in 2007 and 28 in 2018. Back at the top, change count to average and include the HH size persons variable. Change the table to a heat map to add some color. Scanning down, is there anything you notice about the household size data? For example, we know there are 28 households, so 10 less in 2018 than 2007. We now see one household in 2018 was not present in 2007. So, there were 11 households that were in 2007 but not in 2018. They were in the first and third villages. The 10 households in Kasha all remained. There were no small households in Kasha. The minimum size was 7 and was in 2007. In the other two villages, there were small households, and they were often the ones that were absent in 2018. The overall result of about 10 persons per household in 2007 was 11 in 2018. This was reported in the paper that summarized the results. Now, produce a small summary table. take the HHID variable away and put it at the top. We now see that the increase in household size was in 2 of the 3 villages. The only village where all the households remained had an average decrease in household size. Continue with the analysis. Return the HHID variable to the left. Also, add the remained variable. Click on the arrow with the remained variable to add a filter. The ease with which you can filter is a very nice feature of these pivot tables. The resulting data has got rid of almost all the blanks. However, 2 remain in household MA1 and MA11. They are presumably data entry errors in the remained variable. Filter on HHID to omit those households too. Using just these households, we see that the size has decreased from 12 to 11 between the 2 years. Return the HHID to the top. In the summary table, we see the decrease in household size is consistent in all 3 villages. Change the heat map to a table bar chart to include a simple chart. Change to a horizontal bar chart to show the difference between the years and the villages clearly. The third example is of daily climatic data from 3 stations in Mozambique. Use the import from library icon or from the file menu. Go to the climatic directory, then Mozambique, and click on Mozambique 3 stations. Then press open and press OK. There are about 25,000 days of data from each of the 3 stations. 3 elements were recorded, namely the daily rainfall totals and the maximum and minimum temperatures each day. Use Prepare Check Data pivot table as before. Put the year and month into the rows and the day of month into the columns. Then press OK. Then click on Maximize in the output window. The top row shows the data started in 1951 with data from just 2 of the stations. Click on the station name to just examine the data from one of the stations. Choose Nampula first. We see, as usual, we are looking at single observations and the data from this station started in December 1956. Click to choose Sum, then make it the sum of precip and choose to display as a heat map as usual. Now explore the data and slowly. This example was for real and was before we did our main quality control of the data. We found some interesting issues that our automatic checks did not pick up. Do you notice anything interesting here? The first oddity here is 44.5 millimeters on 11th June, followed by 5.5 millimeters on the following day. That's surprising in the dry season, but what is more amazing is to see exactly the same values repeated exactly 1 month later. Notice it is only because we chose this layout of the data that this became obvious. While discussing that, have you noticed anything else? Look at 1980 January from 1st to 5th, and it then repeats on 6th to 10th of the month. Now look further, and you find it isn't just that month. Now, remember you are data detectives. So, how long are the repeats for? And are they just for the rainfall and just for Nampula? Or is this more general? Change the element to the maximum temperature and check 1979 again. We notice the same pattern as for the rainfall. This is a puzzling feature to unravel. So, when checking the data, we look for multiple identical values, sudden changes in value, repeated patterns, puzzling missing values, and anything else that looks odd. Note also the low temperature value of 11th July, which was one of the days with high rainfall. Possibly the June values were there for the error. This all needs checking with the paper records. Now move to the summaries. Move the day to the top and the month to the columns. With the temperatures, change to averages, that's for the means. The data are now the monthly means of Tmax. This now shows the seasonal pattern for Nampula, clearly, with June and July being the colder months. Swap the year and the station name and reinstate the data for all three stations. Add the latitude, longitude and elevation and change the display to table bar chart. You now see that the 400-meter difference in elevation between Chimoyo and Nampula correspond to a difference of about 2 degrees in average temperatures. The pattern of Nampula compared to Saisai is less clear. Extremes can also be examined, though with more caution. Change to Tmin and to the minimums. Each of these values is now for a single day and the main impression is of an obvious data problem in January at Chimoyo. Whenever data checking is done too quickly, you will be dragged back to continue that work. Pivot tables are promoted, unjustifiably, as a way to produce quick tables and graphs. In addition, they can provide a neat way to examine the individual data. We have shown that role in each of the examples, and that is why we also include pivot tables also in the Prepare Check Data menu. We claim that learning about pivot tables in R is just as easy as in a spreadsheet. It is the R pivot table package that is key and nice to have powerful features in R that are so easy.